of patterns. In this short video, we will see how to create patterns with mathematical functions. For this purpose, I am using Desmos. To get Desmos, you just select a web browser and open a new tab and type Desmos calculator in the search button. Then press enter. You got search results like graphing calculator Desmos, scientific calculators Desmos, etc. You just click on graphing calculator Desmos. It will lead you to the Desmos website. See, this is an example of Desmos screen. How to create a pattern with the help of Desmos. To create a pattern, you need a mathematical function. A mathematical function can be typeset in the left pane. Its graph or animated image will be created in the right pane. You can create new cells using this plus sign, that is a mathematical expression, comment node, table, folder, image. For example, you need a mathematical expression. You just click on plus, then f of x expression. Now you go to cell and type the equation x minus y is equal to 3 to create the line corresponding to this mathematical function x minus y is equal to 3. If you want to hide this graph, you just click on the circle. To explain different graphs, I just hide the image and also the pattern created by our mathematical equation. First of all, I will tell you how to create straight lines. Straight lines are of the form ax plus by is equal to c. So you just write down the equation in a function cell. Then click on this circle. The graph will be appeared in the screen. Now, suppose you want to need the axis and also the grid points in Cartesian mode. You click on this grid and select the Cartesian. If you want polar plane, you click on polar grid. Here the xy equation is given, so you choose our Cartesian plane. You need x-axis, so click on x-axis and also click on y-axis. Now the graph is appeared in the screen. Now this plus button zoom in the graph and minus button zoom out the graph. Another equation is x minus y is equal to 3. You can click on it, so this graph is appeared here. Now to find the solution of these two equations, you just click on the intersection point. So the intersection point is 2.5, minus 0.5. Now how to create graph of nonlinear function? You just typeset that equation in the plane. For example, xy is equal to 1, it is nonlinear. It's a rectangular hyperbola. You can add plus x or minus y, etc. along with this equation. So nonlinear equations can also be plotted with the help of Desmos. Just hide this equation. Now we think about inequalities. Suppose you have to draw the graph of the inequality x plus y less than or equal to 8. You just typeset that equation in the function cell and activate the graph. See, it's a region bounded by x plus y less than or equal to 8. Suppose you want to get the graph of x plus y less than or equal to minus 2, you just typeset it. So you got the region bounded by the line x plus y is equal to minus 2 and below that line. So hide it. Now we move on to polar representation. How to represent mathematical equations in polar form. You are already familiar with this idea in complex functions. For example, I just create a function r is equal to cos theta. The graph is appeared in the right pane. It's a circle on x-axis. If you change cos theta to sin theta, you got another circle, but that circle is on y-axis. You can add constant along with this theta as a coefficient. Just put 6, it creates another pattern. Whenever there is a number come along with this theta inside the sine function argument, it is the frequency. When you just put a number just behind this sine function that becomes amplitude 5 cosine theta. It amplify that function image. Just zoom out. Got it. Now we move on to another equation. R is equal to A into 1 plus cos theta. You just plot it. It is in the point form. We can change this point form into solid line using this edit list option. Then click on the circle, change into line style solid. We can use different color for the graph also. Done. So this shape is called cardioid. Instead of this plus, if you put minus, it creates a cardioid in the opposite direction. It's a mirror image of 1 plus cos theta. Suppose you want to put sin theta here, it creates another cardioid. Another interesting thing is that you can choose different parameters along with this function. Here we have already A. When we put A here, it creates a slider here. Slider is actually a looping variable. When you click on the slider, you get a slider with the name A. This slider will vary the value of A from minus 10 to 10. If you allow the slider to move, it creates a graph like this. Suppose you want to add one more thing or one more parameter here along with theta. As you know, it is frequency. I choose here n. So Desmos will hint add a slider. Click on add a slider. You can fix the value of n by clicking on the lower limit. Here I put n is equal to 0 as lower limit and n is equal to 6 as upper limit, and step size is 0.5. Then allow this n to vary. So it creates different images based on the values of n. Now I can change the value of a here, then a to some 1.7. It creates an animation like this. If you allow a to vary, it creates a 2 parameter system of curves. One is a, another one is n. Next function, that is r is equal to a into cosine theta. You just activate the graph. Here again it is a point. You just run n values, so it creates the pattern of points. If you allow a as in the previous plot, it amplify and also contract. You can change the line type by clicking on edit list, click on the circle and change line type and also the color. So these patterns can be created with the help of simple mathematical function. Thanks for watching this video. In next video we will discuss more patterns using Desmos.